For my final year project, I developed a genetic algorithm to solve an economic dispatch scenario. This was written in Java, and the data was subsequently graphed in Excel. This challenge was addressed over several stages. Firstly, creating a dynamic landscape using real-world data. This involved sourcing power usage data from AirGrid and logging it into the program as essential structural data. Real-world power generator data was also procured through AirGrid and used as limitations for the power generation area. Secondly, developing a genetic algorithm that would take each 15-minute increment of power demand and using the power generation capacities available, provide multiple solutions for each power demand situation as it arose. Thirdly, creating a costing function that would enable us to encourage certain generators to be used rather than others. In this scenario, each generator was assigned an environmental rating at random, and this element was used as the costing function. In other situations, this could be modified to be the cost of procuring fuels or down to personal preference. The idea was that the weighting would be adjustable by design. The costing system itself involved running each solution from the genetic algorithm through the costing function and assessing the price, ideally aiming for the least expensive. And finally, testing. This consisted of running the program under different scenarios, such as over multiple days with different generator setups, different levels of mutation, increasing and decreasing the number of values returned for each requested value, and finally, increasing and decreasing the size of the generation caps in the genetic algorithm, all in order to optimize the runtime and still ensure an efficient result.